Well, hello everybody. I'm delighted to be here. As Clodagh mentioned, my name is Jennifer McKenna and I'm from Intel Ireland. I've been with Intel 10 years, and for the first 7 years I was a process engineer in the fab. And for those of you who don't know, fab is short for fabrication. That's what we call our factory out in Leixlip. And for the last 3 years I've been a European research project manager in the Silicon and Nano Research Group out on the same site. So I'm sure you are all familiar with what Intel produce, and if not, you definitely are now after seeing that video. We make the microprocessors that go into PCs, laptops, and are now available in smartphones. And it was about this time 10 years ago I was writing up my PhD. I had done a PhD in organometallic chemistry out in DCU, and to be honest, I needed a job. And on the student notice board, I saw a vacancy for Intel, looking for process engineers. And they were looking for anybody who had a scientific discipline. And so I applied, to be honest, not really knowing what Intel did, where they were located, etc. But before the interview, I did my research, and I'm happy to say that I passed the interview. Within the first week, I was given a laptop. I was given a phone, and I thought this was great. And this was a time when mobile phones were not a common accessory, and nor were they the small type that just fitted in your pocket. They were the kind of type, you know, the brick type, very heavy to use. But as I said, I started out as a process engineer. I was given the responsibility of looking after one instrument that did a certain chemical process to produce the transistors. And at the time, Intel Ireland were producing the 90 nanometer transistors. So just to put that in context, if you think that the diameter of a hair is 90,000 nanometers and the smallest thing that the eye can see is about 40,000 nanometers, you'll appreciate just how small the dimensions of the transistors we were making at that time. So I owned one instrument that did a certain chemical process, and it was my job to ensure that that instrument was always in good condition to produce a quality product. Within a year of joining Intel, I got sent out, along with about 200 of the other Irish employees, to the Oregon site out in Portland, Oregon. We were starting up the new technology in Intel Ireland, which was going to be 65 nanometer technology. So I was transferred over there, and I spent 14 months there working on the same instrument type, but learning all the issues that it would have. And as you can imagine, when you are dealing with such small dimensions, there are going to be a variety of problems. And how you would deal with them, how you would notice them, how you would fix them to ensure that every transistor that we did produce came out with the yield we expected. I loved the fact that I could travel, because this was one of my other passions, as well as being passionate about science. And after 14 months, I came back to the Intel Ireland site, and for the next probably about 18 months was involved in what we call up the startup technology. So this is where all the instruments, and there's about 500 different process steps that are needed to create the transistors that we produce. So they have to be installed. All of them are installed against a certain set of criteria and have to be qualified to run production. And then for a year, we start ramping up the factory. So we start off maybe making 500 wafers. And if you saw in the video, those round discs we produce are called wafers, and they maybe contain about 400 to 500 individual transistors. So we process in terms of one wafer at a time. So for about the first 18 months, you are qualifying the process. You are then ramping up to your maximum number of wafers per week. And there's a great buzz. It's such an energy about the place. It's like we all team together, the 4,000 of us engineers, technicians, everybody who's there on site, because we all want to be the best. We all want to get the best results that the Intel can produce. Thereafter, you go into a sustaining type of mode where you have proved that your site can produce the quality product, and you are now just continually trying to improve the process, trying to maybe bring in cost-saving measures, or trying to get more out of your instrumentation. Thereafter, I got the opportunity then to try a new challenge, and I moved into the Silicon and Nano Research Group. And my current job is I'm involved in European projects that look at new materials for future transistors. And when you think that we are now, Intel Corporation is now producing 14 nanometer dimensions. You can imagine going from the 65 to 14 that there are a lot of challenges with the materials that we are working with. And the type of roadmap I'm looking at beyond the 5 nanometer dimensions. So we're involved in many projects that are looking at materials that can produce the performance that we need in the transistors at those small dimensions. And I have to say that working in Intel every day is different. You get to work with such great people. And just because I had a chemistry degree, you might not relate that as being relevant to what Intel does. All kind of scientific disciplines are present in Intel. We have electronic engineers, mechanical engineers, physicists, chemists, a variety of qualifications. And the idea is that if you have a scientific mind, you know, those skills can be applied to what we make in the factory. And as you saw probably from the pictures, our factory is really highly automated. And when I started there, I think I was in awe for about a year. It reminded me of Star Trek. You know, everything was just so cool, so automated. All that was missing was the kind of beam me up platform. And another fun part, as you probably saw from the video, is that we all have to gown up in these special suits. We call them internally as bunny suits. I don't know where that name came about, but that's because we work in a clean room environment, which is very different and takes a while to get used to. But I'm telling you, when you're gowning up every morning to go in and have your morning pass downs, you can get very quick at putting on that suit. And another funny thing is you begin to recognize people by their shapes or sizes or how they walk. But it's a fantastic environment because you are working on some of the leading edge technologies with some of the most fantastic scientists. And currently through my job in research, I get to coordinate with a lot of our researchers based out in Intel Oregon who actually create the new materials, the new processes that go into our new transistors. And just to finish, let me also remind you that for these big, huge technology companies, as well as needing all the scientists, we have a finance department to make sure we're balancing our books. For all the equipment that we use that cost millions, you know, they must keep track of all those costs and all the depreciation costs. And we have a huge automation department because, as you can imagine from all the automation you saw there in that video, there's a lot of software working behind that. And of course, to recruit all you new guys when you finish up, and we want you to come out working for us at Intel, we need HR staffing. So as well as the technology being the kind of core area of Intel, we have all these auxiliary departments that are hugely important. And just one final point, it's estimated that in the future, 75% of jobs will be technology related. So if you consider the societal challenges that we face, you know, growing old, your kids in the future will probably have a great chance to live till 100. So we probably need a lot of technology to support them as they grow old. And what about climate change? How are we going to resolve that issue? Well, you can bet your bottom dollar there'll be a technology aspect to the fix on that issue. So with that, I think my 10 minutes are probably up. I'd like to thank you for your attention, and I'll be mingling around later. If you have any questions, please ask. Thank you.